Welcome to the fascinating world of umami, where 1 plus 1 doesn't equal 2, but something much more delicious. Umami is the fifth basic taste, and it has a secret superpower that defies simple addition. Let's start by understanding what umami actually is. The word umami comes from Japanese, and literally means delicious taste, or pleasant savory taste. It was discovered by Japanese chemist Kikunae Ikeda in 1908 when he isolated glutamic acid from kelp. For centuries we knew 4 basic tastes, but umami became recognized as the 5th fundamental taste. From an evolutionary perspective, umami taste helps us identify protein-rich foods that are essential for survival. Now let's dive into the molecular magic that creates umami taste. The primary molecule responsible for umami is glutamic acid, or, more specifically, its ionized form called glutamate. Glutamate is an amino acid that binds to specific taste receptors on your tongue. The chemical formula for glutamic acid is C5H9NO4. Different foods contain varying amounts of naturally occurring glutamate. Ripe tomatoes contain between 140 and 250 milligrams of glutamate per 100 grams. Aged Parmesan cheese is incredibly rich, containing 1,200 to 1,680 milligrams per 100 grams. Soy sauce ranges from 400 to 1,700 milligrams per 100 milliliters, depending on the type. Here we can visualize the relative glutamate content, with Parmesan being the champion of umami-rich foods. Here's where things get really interesting. What happens when we combine umami-rich ingredients? Let me ask you a question. If one ingredient has an umami intensity of 5, and another also has 5, would you expect the total to be 10? 5 plus 5 equals 10, right? Well, not in the umami world. The answer is not 10, but potentially 20 or even 30. This is the umami synergy effect. When ingredient A with intensity 5 combines with ingredient B, also at 5, the result can be 30, not just 10. This phenomenon is called umami synergy, or the multiplicative effect, and it's what makes food chemistry so magical. Let's understand the molecular mechanism behind this synergy. 2 key types of compounds work together to create this synergy effect. First, we have glutamate, found in MSG, tomatoes, and aged cheeses. Second, we have ribonucleotides, specifically IMP and GMP, found in meats and mushrooms. When glutamate and ribonucleotides meet, they create a synergistic network of taste enhancement. We can express this synergy mathematically with a special equation. The total umami equals the glutamate umami plus ribonucleotide umami plus a constant K times their product. The synergy constant K ranges from about 1.3 to 8, depending on concentrations. Let's work through a real example to see this in action. Suppose glutamate umami equals 5, ribonucleotide umami equals 5, and K equals 4. The total umami equals 5 plus 5 plus 4 times 5 times 5. That gives us 10 plus 100, which equals 110. That's an 11-fold increase. In typical cooking scenarios, this synergy can amplify the savory taste by 4 to 8 times the simple sum. Now let's explore how this works in real dishes you know and love. One of the most classic combinations is tomato sauce with Parmesan cheese. Tomatoes provide 200 milligrams of glutamate, Parmesan provides 1,400, and together they create exponential deliciousness. Let's calculate what happens when you add Parmesan to your tomato pasta. Imagine pasta with tomato sauce alone has an umami intensity of 10. If you consider the Parmesan's glutamate alone, it might add 5 more units, giving 15 total. You'd expect 10 plus 15 equals 25. But with synergy at K equals 4, the actual result is 10 plus 15 plus 4 times 10 times 15, which equals 625. That's a 25-fold increase in savory perception. This is why Parmesan transforms pasta. Asian cuisines have mastered umami synergy for centuries without knowing the chemistry. Japanese Dashi combines kelp, which is rich in glutamate, with bonito flakes, which contain IMP. Kombu kelp provides 3,000 milligrams of glutamate. Bonito provides 280 milligrams of IMP, creating the perfect synergy. The synergy factor in dashi can be 7 to 8 times, making it incredibly flavorful with minimal ingredients. Chinese cooking combines soy sauce for glutamate, mushrooms for GMP, and meat for IMP. This creates a triple threat of umami compounds, all working synergistically. But why does this synergy happen at the molecular level? What's actually happening on our taste receptors to cause this multiplication effect? Our taste receptor cells have specific binding sites for different umami compounds. The answer is receptor binding amplification through multiple mechanisms. Glutamate binds to taste receptors called T1R1 and T1R3. When ribonucleotides are present, they enhance this binding by 10 to 20 times. The binding affinity, measured by Kd, decreases by 10 to 20-fold, meaning much stronger binding. Both glutamate and IMP bind to different sites on the same receptor, causing a cooperative enhancement effect. This phenomenon is called positive allosteric modulation, where one molecule enhances another's effect. Let's quantify this effect with some real numbers from research studies. Classic research by Yamaguchi in 1967 measured umami synergy precisely. MSG alone at 0.5 grams per liter has a certain umami intensity. IMP alone at 0.05 grams per liter has a much weaker intensity. But when combined, they equal the intensity of 5 grams per liter of MSG alone. That's a 10-fold multiplier. Let's apply this to a practical soup recipe you might make at home. Imagine a base soup with 1 gram of glutamate has an intensity of 50. Adding just 0.1 grams of IMP from dried shiitake mushrooms alone would be intensity 5. With a synergy factor of 5, the total becomes 50 plus 5 times 50 times 5, which equals 1305. That's 26 times stronger than you'd expect from simple addition. This is cooking magic. How can you apply this knowledge in your own kitchen? Strategy 1 is to combine multiple glutamate sources together. Tomato, cheese, and soy sauce all together create a glutamate powerhouse. Strategy 2 is to add nucleotide-rich ingredients to boost synergy. Dried shiitake mushrooms contain 150 to 200 milligrams of GMP per 100 grams. Anchovies provide about 100 milligrams of IMP per 100 grams. Bonito flakes are even richer, with 280 milligrams of IMP per 100 grams. Strategy 3 is using umami-rich ingredients as a finishing touch. Add Parmesan cheese at the very end for maximum sensory impact when it hits your palate. Because of synergy, a little bit goes a very long way in flavor enhancement. Let's look at a more sophisticated mathematical model of umami synergy. The intensity I equals glutamate intensity plus nucleotide intensity plus K times their product. The synergy constant K actually depends on the concentration ratio between compounds. K equals K maximum times the product of G and N concentrations divided by Km plus their product. K maximum is approximately 8, and Km is about 0.01 molar. Let's work through an example with real-world concentrations. Suppose glutamate concentration is 0.02 molar and nucleotide is 0.001 molar. Then K equals 8 times 0.00002 over 0.01 plus 0.00002, which is approximately 0.016. At these particular concentrations, the synergy is moderate but still significant. But if you increase nucleotides by 10-fold, the synergy factor explodes dramatically. Why is this more than just simple addition? Let's examine the perceptual difference. Simple addition gives you a linear increase, but synergy gives you an exponential leap in perception. Remember, sensory perception follows a logarithmic scale, not a linear one. Sensation S equals K times the logarithm of intensity I, following the Weber-Fechner law. This means multiplicative effects at the chemical level translate to additive effects in perception. But umami synergy creates multiplication at both the chemical and perceptual levels simultaneously. Let's clear up some common misconceptions about umami and MSG. Myth number 1. MSG is dangerous or unnatural. This is false. Fact: glutamate appears naturally in every protein-rich food you eat, from meat to vegetables. Your own body produces 40 to 50 grams of glutamate every single day for neurotransmission. MSG is simply the sodium salt of glutamate, chemically identical to natural glutamate. Natural glutamate and MSG glutamate are chemically identical. Your body cannot tell the difference. Myth number 2. More umami is always better. Actually, no. Fact. There's an optimal concentration range for umami, typically 0.2 to 0.8%. Beyond 0.8%, the taste becomes unpleasant and can taste bitter or soapy. Why did we evolve to have this synergy response? Why would evolution favor this complex synergy response instead of simple addition? The answer lies in protein detection. High-protein foods signal survival advantage. The answer is complete protein detection and quality assessment. Glutamate alone indicates broken-down proteins, which might be old or damaged. Nucleotides indicate fresh, intact proteins from recently living tissue. Both compounds together signal a high-quality, fresh protein source that's safe and nutritious. The synergy response essentially tells your brain, this is exactly what you need, eat this. This is why aged cheeses and fermented foods, which concentrate these compounds, taste so incredibly good. Let's summarize the key points about the umami illusion. First, umami synergy is multiplicative, not additive, giving us 1 + 1 = 10 or more. Combining glutamate with nucleotides creates 4 to 8 times amplification in taste. In the umami world, 1 + 1 truly does equal 10 or even more. This works through positive allosteric modulation at the receptor level. Classic food combinations like tomato parmesan, dashi, and soy mushroom all exploit this synergy. The magic of umami synergy, a world where 1 + 1 = 10, and food becomes exponentially more delicious.